All right. And thank you everyone for welcome. A big good afternoon to Dr. Tai-Yi Huang, Corporate VB and CTO of ASUS, panelists and healthcare colleagues. Welcome to CHI Masterclass AI in Industry 4.0, the future of healthcare. Now, before we start with the masterclass, I thought I'd run through the proceedings of today. First up is the masterclass titled AI in Industry 4.0, The Future of Healthcare by Dr. Tai-Yi Huang. And then this will be followed by a panel discussion on stage for overcoming barriers to adoption of AI in healthcare. From there, we'll proceed with the MOU signing ceremony, and we hope that you will be able to join us for this special occasion. Okay, and without further ado, now in the evolution of modern medicine to precision medicine, the process is often hampered by fragmented data and outdated information systems. Now, in this masterclass, we are honored to have Dr. Huang share the lessons learned in tackling these challenges and present innovative solutions that have been developed in response. To share more about our esteemed speaker, may I invite Associate Professor Tan Che Heng, Assistant Chairman, Medical Board for Clinical Innovations and Research at Tan Tock Seng Hospital, and Executive Director for Center for Healthcare Innovation, on stage, please.
Thanks. Thanks for the applause, but let's save it for Tai-Yi later. So I just here to introduce Tai-Yi, who I just met, and we had a good 1 hour conversation. So Tai-Yi is actually the CTO for ASUS AICS, and he received his Bachelor in Science from NTU, but this is the National Taiwan University. And then following which he did his Master's and PhD in University of Illinois. And he's been working with the tech giants, actually Microsoft and Google in the US for nearly 20 years before he went back to Taiwan, and obviously has a rich experience in cloud and software development. So Dr. Huang is currently serving as the corporate vice president and the head of the AI cloud services in ASUS, as well as the intelligent cloud services in ASUS, which is a software division that is meant to advance AI technology and promote digital transformation within the industry. And we are very privileged to have him here today to share his insights on how AI is going to transform the healthcare industry. Thank you.
That's good. Oops. All right, great. Thank you. All right, thank you for the introduction. And dear colleagues in 10,000 Hospital and friends online, I'm so great to have a chance to visit you guys in person. I was not able to travel due to our government is so protective. They treat us like their children. They don't want us to go outside the home and pray. So finally, I was able to travel here and see you guys in person. I know we've been working together so closely in the past 1 year, Dr. Eugene and our team, and we have achieved so much. I just want to come here to say, good job, guys. Congratulations. Let's move forward and achieve more. I want to use some time to share what we have learned in smart healthcare in the past 3 years. But first, let me put some disclaimer about myself. This is a short resume about me, but the key takeaway in this slide is that I'm not a medical doctor, and I have been a patient, and I come to doctors, but I don't speak medical terms. The way we decide to work on smart medicine is that when I moved back from US to Taiwan, the chairman asked me to find something big that if we can make it through, if we can get it done, that we can create a new business and also create a big impact for humankind. And then in the start, 3 years ago, we start talking to hospitals to see is any problem we can help. We as a computer science nurse, we have no medical knowledge, but we can write program for you. What kind of problem can we solve? And then after 3 years, we realized there are actually 2 big problems in today's healthcare that preventing us from going from today's healthcare to precision medicine in the futures. And those problems are data and systems. Particularly, data are so big, so fragmented. The system is so outdated. We expect the data volume to grow almost double every 2 years. With AIoT, with a bunch of smart devices, we're collecting more and more personal health data. However, our system, the system we use in hospital, in smart healthcare environment, are so outdated. Okay, how do we solve this problem? So about 2 years ago, we put together a team. We think about if we have unlimited resource, time and energy and talent, how do we want to tackle these problems? So we come up with this architecture. They set aside regulation, privacy, assuming all these are non-problem anymore. What kind of ideal system we want to provide? So conceptually, in the center, we have a patient-centric database. Okay, we were able to collect structured data from everywhere. We can collect data from hospital, we can collect data from patients. Now the problem is that how can we make people willing to give us data? We must provide the service to them, such as Facebook give you a Facebook social network, you give data to them. Google give you Gmail, you get data to them. So we must offer very good service in hospital that can make sure they love it and they're willing to give data to this patient-centric database. We also want to collect data outside the hospital because patients, when they go outside the hospital, they become a human being. They collect all kinds of health-related data. So we also provide the patient portal apps to patients to collect their data. Now, we have a bunch of data in this database. For example, right now, we have about billions of EMR records in our database. How do we use AI to mine the insight out of it? So the insight will eventually come back to the hospital or patient to provide even better application of service. Okay. Now, the last is that we know the data is always unclean, that there are always errors. Of course, as computer scientists, we need to write a bunch of software to clean the data. But again, computer can only do as much. So we need to introduce human being to come here to clean data for us and teach us how to clean the data. So we come up with a Lumos platform. The principle of Lumos platform is that we want to provide a platform for researchers to use large data to write their research and write their papers. But in the bottom line, we want to use the process to learn from this research how to clean the data. So if we can build these cycles, that we can deploy good service in hospital, good application for patient to collect their data, use data machine learning to compile a bunch of knowledge graph and enable researchers to do research that teach us how to clean data. Eventually, we have more data comes in, more insight come out, and better service. That was our dream 3 years ago. Okay, so based on this architecture, this landscape, we developed a bunch of service landing in Taiwan hospital, more than 20 already. So I'm going to go through 3 demo video and also use a demo video to show our technology develop insight. The first one is about ICD-10 coding assistance. You guys all know that every hospital, I think even in Singapore as well, will hire a bunch of human coder to translate EMR record into code for insurance payment. Okay, that is true for every hospitals. This is the first problem we attack. We say, oh, can we do this with AI? Because human beings are so smart, their brain should be used to something harder for repetitive work, which is AI. So we come up with start with working on machine learning, natural language processing. We get a bunch of EMR records. We construct the EMR record in a graph format. Okay, for example, a patient with a bunch of diagnosis associated with a drug related to our ICD-10 code. And then so if we would be able to construct a gigantic graph to represent the whole situation, we'll be able to align the adjacent nodes and be able to do a prediction. Okay, so right now we have this solution deployed in 20 hospitals in Taiwan. We'll be able to predict CM code, PCS code. The most important, we integrate these solutions seamlessly into the existing workflow. We don't want our the coder or doctor to use another tool. We want a tool to embed it into their daily life cycles. The second one. The third thing, we also believe AI model without constant update is not an AI model at all. So through this deployment, we also seamlessly collect user feedback. User like it or don't like it, they click or they don't select. We use that feedback to retrain our model. So our AI is becoming smarter and smarter every day. Let me show a demo video to demonstrate how we have done it. And this is the POC. This is a product has really deployed in hospital.
Today, we will introduce the core features of Miracle ICD-10 AI Coding Assistant Pro version. Here's how the Pro version can help select the optimal code combination. For example, a patient was admitted with a chief complaint of swelling and pain due to a sprained left ankle. The first two diagnoses listed by the doctor were a fracture of the left tibial shaft and the lateromalleolus of the fibula, both of which were consistent with the reason for admission. In addition to the original AI code recommendation feature in the recommendation list, the Pro version shows the effect of AI recommended codes on the RW score in real time. Hover over the code and observe that SA2.202A has a RW boost of 1.047 if designated as the principal diagnosis. In another diagnosis, SA2.62XA shows the same RW boost when designated as the principal diagnosis. SA2.202A is shown as a valid CC code, and the RW score will increase by 0.849 if designated as a secondary diagnosis. Select the code and enter the DRG Smart Calculator page, then confirm the final results. On the top half of the screen, you can see the current DRG assignment, RW score, principal diagnosis, DRG payment, and profit balance. Current medical payment amount, current length of stay, and the payment thresholds are also clearly visualized. The patient's current medical payment amount exceeds the fixed payment amount and is designated in Zone C. In the lower half of the screen, other than the calculation scores based on other principal diagnosis, there is also the AI recommended principal diagnosis, which presents the optimized DRG assignment after analysis. S72.62XA, lateral malleolus of the left fibula fracture. The RW score increased from 1.0471 to 1.8959 after selecting the AI recommendation. DRG payment increased from -2,000 to 39,279. This confirms the code as the optimized diagnosis for admission. These are the features of Pro version, which are currently available for trial.
So you see that we go from coding assistant. We even penetrate into the payment management. We teach our coder how to optimize their payment from insurance. Our government is not very happy about this, so we'll figure out how to deal with that. Okay. The second project I want to show is actually a project we work together closely with Dr. Eugene and the technician here. It's called Fragmented analysis. Okay, we will try to address 4 problems here. First is that human beings, their energy and resources are always limited. Okay, how can we use machine to replace their repetitive work and use a human brain to do something else? Second one is operator dependence. Okay, different operator has a different criteria, has different trainings, we might produce different results. But machine, once we code it, will produce consistent results. Third one, manual process. Okay, right now, just like ICD encoded, let me share a testimony that in the past, in Taiwan culture, you take about 30 minutes to code IPD, the inpatient, the discharge note, 30 minutes. With AI assistant coding, they can reduce time from 30 minutes to 10 minutes. Okay, just human by selecting and corrections. Again, here, we want to reduce human process time by more than 50%. And last one, right now, you need to sit in the lab to do this in a real chair, in the real monitors. With this, we will enable doctors to do this at their home, when they have coffee. And we have deployed this in 4 test sites. So far, the feedback is always good. They say it feels much faster than a manual process. The accuracy is good enough. Okay, so we are trying to expand it to more sites to collect more data and try to collect more features from users. Again, let me show this demo video to demonstrate how we have done it.
This video features the usage of Blade in clinical workflow. The medical staff starts by uploading the digital image of the peripheral blood flume. The AI model processes this image, and the user can enter the task to review the different white blood cells which have been pre-classified by our AI. Upon finding a misclassified cell, he will simply reclassify them into the right cell type. Next, the user can review the slide image, and he can note any observations in the comments box. The user can also enlist the red blood cell functionality to assist in cell grading. The user selects a region to calculate red blood cells within that region. A reference of the required number of red blood cells for each grade is calculated. As an example, anywhere between 1 to 2 schistocytes qualifies for a grade of 1+. No schistocytes are seen here, hence the grade remains as 0 and no grade needs to be reported. After red blood cell grading, the user can also opt in for platelet estimate. A field of view corresponding to 10 high-power fields is shown, and the user can generate the platelet estimate. Within a few seconds, the average platelet per field and platelet estimate are generated. All of the assessments are collated in a report for final review. Upon completion, the user can sign off the report and have it uploaded into the lab information system.
This is well done, a very nicely done tools. I think if you're a technician, right, I could not imagine how you don't like these tools. Thank you guys. Thank you for David and Dr. Eugene for such a wonderful job. And also I want to mention one thing. When I conduct our projects, I even mentioned this to Dr. Hunter in the lunchtime that we measure our success by usage. Okay, the more people use it, the more successful you are. So it means that we don't only focus on the algorithm accuracy itself. We focus on user experience. How seamlessly integrate with user flow. Does the UI represent the most insightful information? Does it reduce this distraction from the users? That's how we did the work. The last demo I want to show you this one. We also developed, I don't have time to show the demo video, is that we also developed a patient app. In Taiwan, I don't know about in Singapore, people go to hospital a lot. Okay, so for any kind of disease, they go to hospital. So we provide an app to enable patients to interact with the hospital in a more electronic way. For instance, start with number 1, booking. You can open the app, type in your diagnosis and then symptoms, and then the app will recommend you which doctor you should book. Second one, you have to know your queue status, which number you are queue. Third one, you can do the predictions when you should come to the hospital. Without this app, we often come to the hospital 1 hour, 2 hours earlier, sit there and wait there for wasting time. But with this one, we can predict the queue progress and tell you only come to our hospital 30 minutes before the time. And then health passport, previous Q&R. We also provide a tool, allow the patient to write down or speak up their symptoms. And that information will be transcribed and then documented and present in front of the doctor's windows. So when the patient go to the doctor room, the doctor will see the information provided by the patients. So all this, we have provided an app deployed in 2 hospitals already. So every day it's about 1,000 users using our app. The last demo is about our Lumos platform. Let me remind you, Lumos platform is a platform to enable researchers to do research. Okay, we collect a bunch of data from the hospital, either inpatient record, outpatient record. We structuralize, clean it, and provide a Google-like search platform for researchers to come in and conduct their research. I'm going to show this video to see how a doctors or researcher can use platform to do research.
ICE Lumos offers retrospective cohort study design and statistics analysis results. Data extraction follows the PICO model: population, intervention, comparator, covariate, and outcome frameworks. Here is an example comparing the treatment effect of canagliflozin and other oral hypoglycemic medications on the risk of heart failure in patients with type 2 diabetes. First, the experimental group was set up. Population was defined as adults with a primary diagnosis of type 2 diabetes. Patients with a previous diagnosis of type 1 diabetes were excluded, and canagliflozin was entered as the intervention. Patients who had used other SGLT2s and other hypoglycemic drugs were also excluded. Do the same setup in the control group for the population of interest. But instead, other hypoglycemic drugs were chosen as intervention in the control group, and patients who had used SGLT2 drugs were excluded. Next, define the covariate. In this study, the comorbidities of hypertension, hyperlipidemia, and atrial fibrillation were set as the covariates for the analysis. Lastly, in outcome, the occurrence of heart failure events was set as the primary endpoint. At this point, preliminary research design is completed. After pressing compare, Lumos performs a statistical analysis. Lumos first analyzes the differences between the experimental group and the control group, including age, gender, covariates, and other clinical characteristics. The incidence rate was produced as the main outcome set in the study. Kaplan-Meier curve presents the incidence rate of the outcome of interest in the experiment and control group. Finally, the Cox regression presents the hazard ratio of the experimental group compared to the control group. With Lumos, you can save a lot of time in data cleaning and preparation, and get preliminary analysis results from complex EMR data in a few minutes. Lumos can significantly enhance the efficiency and productivity of research of real-world data.
Yeah, we have been using this Lumos platform on 7 of the hospitals in Taiwan. They ported our data into our platform and enabled our researchers to data mining, pre-analysis in a much faster time. There are several papers being published through this platform. In fact, the doctor even told me that for typical data analysis problems, in the past, they used to take months, go through technician to collect the data, mine the data, redefine the hypothesis. They go through months. With this tool, they can get it done in 5 to 10 minutes. That is a reduction, the time reduction we save for our researchers. So in conclusion, those are the solutions we developed in Taiwan for more than 20 hospitals. The daily user, the monthly user now is about 30,000 and even growing more. The most important, our usage grew 10 times in the past 1 year. That means that our services are popular, are welcome in Taiwan. But one small thing, when Steve Jobs sat on stage, right, and said one small thing, that usually is a highlight of the talk. One small thing, we are about to fail. We are almost failed. Why is that? Let me show you this. Any business product start with talent. You use a mind to hire talent, and then you develop product. Product has a value, but most important is a profit. With a higher profit, you are able to pay your talent and hire better talent and be able to provide better product, come out with better profit margins. Okay, that is a healthy business cycles. In smart healthcare, I don't see any health business cycles. Okay, why? But let me go back to the software business. What kind of software business has healthy profit cycles? They need to maximize their profit so they can hire the better talent. Okay, how do you maximize your profit? Reduce your costs through platform, through standardization. For example, I just use Grab, right? Okay, Apple Pay. Everybody use Apple, right? Apple Pay connect the customers and to their wallet. So Apple Pay build a platform to be able to get money from each of you. Now with the platform, they can open for all kinds of innovation on top of it, such as Starbucks. You go to coffee, you present Apple Pay, they call the API, they get the money from Apple Pay through your wallet, get the money from. So Starbucks can focus on their business. Grab can focus on their business. Through the platform, they are able to provide the maximize the benefit for both Apple and Grab or Starbucks. We don't see that in smart healthcare. In fact, if we don't solve this problem, I don't think anyone will be able to survive in this industry. Why? There are two big problems here. Let me use computer science term to define what's the problem, and hopefully at the end you understand our struggle, and then we can work together to solve these problems. In the ideal case, right, this is a hospital. At the bottom, they have a database. Let's say you use Oracle, the database. On top, they have the business flow, the UI. Okay. Ideally, in the second hospital, use the same business flow, the same data structure, the data schema. Then the code itself can remain the same. Ideal case. In that way, you have same UI, same clinical workflow, same data model. Then you can develop AI application on top of this common platform. That is the ideal case. However, the problem is that across the whole globe, the hospital choose to use their IT to develop their own system in the past 20, 30 years. They start with written, convert the EMR, but they treat IT as their in-house staff to develop. And this becomes ugly reality. Okay, one hospital decided to use SQL. So So they change the database, change the data schema. They need to change the store procedure to access different data. They have different procedures, different steps, different UI. They need to change their clinical workflow, regulation rules. At the end, is that the different functions, different layout, different code base, different data model. It becomes a very, very fragmented systems. Just like imagine all your iPhone has a different OS. To write application on top of your iPhone, you need to integrate with every OS. How can any business survive in this environment? So the problem in common is that very poor data interoperability. For example, this is two hospitals we see in Taiwan. One hospital is bigger, has 3,500 tables. The second hospital has 2,000 tables. The first hospital used 42 columns to represent a patient. The second hospital used 62 columns. So by such poor data interoperability, how can anyone write application on top of it? How can anyone efficient integrate the data, label the data, and come out with clean data models? So the result is that the development cost is very high. Okay, the maintenance cost is also very high. Think about it. If everybody need to write their payment system, Starbucks, Grab, Uber, anyone want to write their payment system, what kind of waste that cost on the society? So the very large maintenance cost. The most important is that there's low interest for AI developer to come in. Or whoever that come in with a patient, eventually their patient will die out because there's no profit out there. Okay, so in conclusion, that it's about 1 year ago, we realized that if we don't solve this problem, we will die. Houston, we have a problem. Again, we have a huge problem in front of us. We need to work together to solve this problem, to create an ecosystem that you will win, we also will win. Think about it. If ASUS was such a big company, such a sufficient funding, if ICE failed because we cannot find scalability, who will be your next partners? How long can they survive? And what will smart healthcare in the future? Okay, so 1 year ago, we realized that we must address this problem head to head. So we come up with a very ambitious approach. We call it, we decided to rewrite the HIS. But we want to rewrite the HIS in a way that every hospital use the same code as a common platform. But you must say, are you so naive? But every hospital want to have that customization. So we also want to address that through different customization. Different the data lake will have a different data converter to convert the data schema into one common schema. For the business flow, we want to use a state engine to allow the customer, the hospital IT to use no-code configuration to change the business flow. For the UI, we provide a bunch of widget framework for application developer to reuse those. If we can achieve this ambitious goal, then we have a same platform code. Each hospital has their own database and a flexible and service application. That's our dream. Okay, so the motto for us is that we want to go big or go home. Because if we don't solve this problem, there's no future between you and me. Okay, and but if we can solve this problem, we can come up with a system we allow the 10x development speed, 1/10 of maintenance cost, and then 10x of the developer in AI to help us. So I encourage you guys to face this problem, work with us to solve these problems. Don't just work on this silo problem, because eventually you will not scale us. Let's address these fundamental problems so we can have a future together. Thank you.
Well, thank you, Dr. Huang, for that very insightful sharing. And now, for the panel discussion on overcoming barriers to adoption of AI in healthcare, please welcome our panelists who will join Dr. Huang on stage. Professor Benjamin Seet, Deputy GCEO, Education and Research, and Group Chief Research Officer, National Healthcare Group. Dr. Eric Wong, Group Chief Clinical Informatics Officer and Deputy Group Chief Data and Strategy Office, NHG. Dr. Eugene Fan, CHI Fellow and Consultant for Hematology, Tan Tock Seng Hospital. Moderating the panel will be Associate Professor Tan Che Heng, Assistant Chairman, Medical Board, Clinical Research and Innovation. May I also invite Dr. Huang to join us again on stage.
Firstly, a very big thank you to our panelists for making time, and also to our participants online. We Hi there, and I'd just like to say that we apologize. The program is going to run about 10 minutes past time, so about 2:10. But maybe let's go ahead and kickstart the panel discussion. Today we have here, and I think Tina has very nicely introduced all of you, but the reason you are here is because you will share different perspectives. So obviously, Tai-Yi, our collaborator, as well as from the industry, Ben for insights from perhaps a more cluster and national kind of an ecosystem perspective, and actually Eric double heads as a TTSH CMIO as well. So very much addressing some of our local institution needs, and our clinician innovator, Eugene. So maybe I'll just go quickly and ask Tai-Yi firstly. You talked about actually one of the very key barriers to development and deployment of AI, but perhaps can I ask you maybe more generally today for your insights on what are some of the major shifts in Industry 4.0 that are leveraging on AI quite successfully today. And the purpose I ask this is because we may want to draw some lessons from some of those other sectors and bring them into healthcare.
Imagine across the whole industry. Yeah, I think the industry sector that adopt AI the most successful is the one who has a huge platform layers. For example, I know Microsoft, Google, Facebook, their AI engineer can reproduce business value because they have a common platform. They solve one problem, they can provide brings in millions of revenues there. Okay, so platformization again is the key. So if an AI solution can only deploy in one or two business, one or two partners, that won't scale. So think about what kind of business has the most platform effect. Those are the areas will attract the most AI talents into the areas.
Thank you. Thank you. That's a good perspective. Can you share how you think in healthcare we can do that? Of course, you mentioned that you are developing your own platform as a way to address that solution. But I believe that the majority of the healthcare sector actually still is very fragmented, as you described. So what is one way to overcome that, understanding that there are so many players in the industry?
Honestly, you have a solution. We won't be working on Axis. Okay, no one want to work on his system. In fact, my colleagues in Taiwan even told me that if you want to kill your friends, just ask him to work on his. Okay, his is a very legacy system. We refused to work on his until last year because we cannot find any solution to work around the data fragmentation and system fragmentations. So if you ask me honestly, I don't see any efficient way to do it. But if one or two small, if you have to start with a small company, 3 or 5 engineers, you might be able to just do a silo device. Okay, because if the whole data infrastructure is derived from the HEAS database, and then go from to the leads, nurse, and then the end device. If you want to provide device on the end device, it should be okay because people consume your data. But the more you want to go inward into the data platform, then you need to deal with data fragmentation and system fragmentation. I don't see any ideal way to solve this problem. Sorry.
Yeah. Okay, thank you. And before I move on to Ben for his take, maybe very quickly to address this, Eric, I saw you took down some notes as well, and you must have thought through some of these challenges for the hospital. What are your thoughts on that?
Right. Thanks. I'm just actually trying to actually go and learn something along the way. I think Tai-Yi actually brought up a very good point. In fact, that we have actually in fact growing our organizations. The data as well as the system fragmentations are actually very real challenges. Without addressing them, it's actually going to be very difficult for us to actually go and move forward. Given the fact that, I mean, in order to actually go and drive AI, the data is actually really the fuel that is actually required. And I think for any one of us who have actually been touched on some of the data project would know, actually the analysis part is actually not that difficult. The data cleanup, the data harmonizations, and it's actually always taking up quite a significant portion of the work. But at the end of the day, the other question is that after you have actually done and get your results and you actually get a pretty nice engine, how do you actually go and put it in where it actually belongs, which is actually where the effect of this knowledge can actually be done. So in fact, I mean, the two notes I jotted down is fact is actually the system and data fragmentations. I do agree that those are actually in fact fundamental areas that we need to address before we can actually go and even talk about, you know, how we actually go and populate AI, how we actually go and, you know, get more of our team to actually go and be trained to actually go and know how to actually go and use these new technologies. Thanks.
Thanks, Eric. I'll ask you about Epic in a while. So maybe moving on to Ben, and I think the reason we wanted to invite you here is really your thoughts about how AI was developing locally as you saw it in the RIE ecosystem. So maybe a very first broad question is AI in healthcare a hype rather than a reality?
So I'll come from the perspective of my previous job where I was managing grants at A-Star, and even in NHG we do manage our own grants. And I think when I look at grant applications, easily 40 to 50% of grants today have the word AI or machine learning in it. So it seems like many doctors, healthcare administrators, think that you can almost AI everything in healthcare. And I'm going to draw two lessons, one from the medtech industry, one from drug development. And I think when you look at medtech, a lot of times the word that we always use quite a bit is this a tech push? So the technology trying to find solutions rather than a problem where we use technology to solve. When you look at drug development, I think when you look at FDA as well as even in Singapore, we use the word, the phrase target product profile, which is what you go through in a very systematic manner to say, is this drug even worth developing and whether there's a market for it. And it looks at who will use it, how will the doctor use it, will it be administered as a tablet, as an injection, what's the market share and so on. And I think while there are many efforts, initiatives to say we can AI this, can AI that, the process of analyzing, is it worth doing? Is somebody going to use it? Is it implementable, scalable? Is it going to make money? I think those are issues that we are not very good at this point in time. So I see it as a lot of tech push, but there are obviously very useful clinical applications, some of which were talked about today. I mean, even in Singapore, eye screening using retinal images, I think AI has made a huge difference. But that process of deciding what to AI, who's going to use it, and how to prioritize which project to pick, I think that needs to be better thought out as by the industry as a whole.
Okay, thanks.
I can answer that. I think AI is not a hype. Look at the product we developed, ICD-10 assistant coding. People love it. Okay, the problem, I think the technician love it. The problem is that development cost is too high. Okay, if I need to spend 10 engineers to work to serve one customer, that will never scale. So AI for smart healthcare, I think it's the right direction. The problem is how can we make it scalable? How can we make it profitable so people are willing to invest more resources to do it?
Thank you. Thank you. Certainly a good point. I think many of our projects actually start off with grant funding and then later on start thinking about commercialization, which actually, you know, creates that valley of death. I think, Ben, another question would be, and you alluded to it somewhat about opportunities, it may be in the context of what, you know, overall we are doing in the health system, healthier SG. Where do you think are some of the opportunities that AI can create for our practitioners, for our healthcare workers?
I mean, if I were to broadly look at potential applications, it's used quite successfully, I think, in image analysis. So helping to interpret X-rays, pathological slides, photographs, moving to dynamic images, echocardiograms. I think I recently saw a report about laparoscopic videos. So I think that is provides where there is a use case, like the reading of peripheral blood films. I mean, 500,000 in just tantoxing every year. So things like this, where it's highly scalable, I think that there are opportunities. When you go in to look at clinical phenotypes, trying to merge it with genomic information, and then after that, even beyond that, into lifestyle information, I think it gets more and more challenging because there are obviously barriers to even merging lifestyle data with his information. So I think those we will really have to be very, very careful. And the rest, I would say efficiency. So ICD coding is efficiency, patient management. Some could be useful, some may not. If it doesn't involve direct patient medical records, I think it's easier to implement. So I'll say that there are certainly opportunities. But again, I go back to my earlier point, we have to be very careful which one to do and what to do.
Thanks. And Eric, of course, you chair the AI committee for the hospital. Where do you think are the opportunities for us as an institution?
So I agree with what Ben has said. I think two big areas that I think we can focus on. Number one is traditionally what is actually the value of AI that can actually go and really bring to us. In that sense, a lot of the new technology, for example, like you have actually mentioned deep neural net and things like that, are very good in doing image analytics. Yeah, so I think those are actually areas that we should actually go and explore and continue to push forth. On the other hand, we also want to actually go and take a look at what we are strong at, because when we are strong, then getting the closed loop to actually go and bring the AI back to the production is actually going to be much easier. And in fact, if I were to take a look at Tantoxing strength, we have actually been doing a lot of data collections. We have vast amount of data sets. We have done major work in, in getting the data standardized, getting the data to be consumed in our enterprise data warehouse. So to me, those are actually really the treasure trove in terms of, getting the digital phenotyping for these patients that we can actually go and do a lot of analysis on. And to a certain extent, we have actually also been incorporating quite a lot of our social and economic data, by either the nurses doing the questionnaire when the patient comes in. These are actually, in fact, a lot of the data that we have actually not tapped into. And therefore, in order to actually go and tap for us, quite a lot of the technology, for example, like NLP and quite a lot of the digital transformation, in fact, is actually something that we should actually go and start exploring as well.
Thanks, Eric. And to the point about standardization, so Epic, right? With NUH, and NHG coming on board, is that going to be the part of the solution to the whole problem of heterogeneous data?
I would say, okay, so it does introduce its own problem, okay? I have to be very honest. But I think on the other hand, it actually does allow us to actually go and take one step forward to where we want to be. Number one, within the whole system itself, we have actually in fact consolidated 89 of our legacy system into one single system. And that means that all the data will flow, all the data actually also have the same definitions as well. But that is actually in fact not going to be enough, to be honest. We have also wealth of legacy data, like I actually mentioned earlier on. So in fact, within the EMR system, which is actually mainly where we actually go and do our transactions, at the analytic, the Tantoxing team as well as the NHG team have actually been doing our data analytic infrastructure project to actually go and really standardize quite a lot of these data, making sure that when, across the institutions, all of the data actually go and talk about the same definitions. And this is actually, in fact, a co-drive together with the MOH team as well. So I think nationally, cluster-wide, as well as institutionally, we are actually, in fact, moving towards where we want to be.
Thank you. And I think we can talk as much as we want about systems, but really on the ground, you need the clinician with their problem statement and their use cases. So Eugene, congratulations on getting your project scaling across to the other institutions. Perhaps this is a good time for you to share very quickly your journey as a clinician innovator, and what advice would you give to the budding clinician AI innovators?
It's been really enriching, just sitting here and listening and absorbing, all the insights. We are on the ground, and obviously the clinicians will face problems, both in the lab and the ward. And every day when I come to work, I keep thinking, what can I do to make my patients' lives and the condition better? One of the problems in our lab was really physical review of blood films. So one day after Chinese New Year, I came back and there was a ton of blood slides for me to look at. I said we can't continue like this. We must have a solution for our staff, so that we can have less fatigue and obviously go for early morning coffee. But yeah, jokes aside, I think really very privileged. It's a real privilege to be in this ecosystem. So it's not a one-man show, and really want to thank CMTI that have sort of seen us through the journey, as well as the whole setup. Also, obviously, our partner ASUS, really very solid team. We have weekly meetings, and yeah, David, the product manager, really depend on him. Obviously, we give the clinical inputs, but the programming, the regulatory muscle, everything comes from ASUS. So I think it's a partnership that is good, because there's both needs, clinical needs, as well as the technical know-how. The clinicians can dream of XYZ program and this and that, but we really need the engineering muscle and the expertise to be able to actually drive our innovative dreams together. So yeah, I think really privileged at this point, and
Yeah, thanks. One piece of advice to give to our clinician innovators is the project started as a startup project to set up startup. Unfortunately, COVID came, so really, I mean, our very board had to do PR instead of making a film. We're all very busy for the 5 months. Project videos and all, doing research, data, startup kit. So we can't continue, we have to move on. We moved on to Amazon. But there's a Chinese saying called
there's a Chinese saying called "Sai Weng Si Ma." So there's for those non-Chinese here, it is really a story about someone who lost his horse, but the horse came back with like two other horses. So really, I mean, I lost a very good partner in the startups, but really got even better partner with ASUS, and look forward to continue working. But the adage is really don't give up, keep trying, and work with your team well. Yeah.
Thank you, thank you. And we are running short of time. Maybe a question to each of the panelists, just in a few words. The question is really about future gazing, and maybe I'll start with Tai-Yi, because you must have given this a lot of thought. In 10 years' time, where do you see the maximal deployment of AI in healthcare?
10 years time, the maximum deployment of AI in healthcare. If you want to bet, I still will bet on those clean data like image. Okay, those are because that's the barrier is relatively low. So I think that is the area where people will adopt a lot of AI solution. It is homegrown or commercial solution. The last chance will be more on this dirty data like EMR records, data-driven stuff. The other area I can also predict the drug development, because those are also clean data. Yeah, so if you can, that's why pharma they invest so much money into this AI. So I think those are two areas I think I'll predict.
Thank you. And Eugene, besides the blood film, where do you think you can deploy it in your practice?
I think there are basically two waves. One is the digital wave that the lab is seeing now. So we're following chest X-rays, where in the past when I was at MO and Eric was my registrar in ED, we used to put up the films and look. But now everything's computerized. Pathology is going down that route. So we are catching this wave along, and we need to ride it well. And there are lots of opportunities actually in terms of the digital space. And Tan Tock Seng does have that significant number of data plus clinicians to drive it.
Thanks. And Eric, how do you see it in, say, Tan Tock Seng, for example?
I don't have a good lens to where we're headed. I think we are still at the starting point. Actually, I mean, as compared to the term AI, I actually like the term ML more, because machine learning actually implies a degree of a continuous learning, and I think we do need to actually go and continue to learn. Having said that, I think there are two things that I hope that to see. Number one is that we want to actually go and really put the angle inside. For the clinicians here, I think you all know the common saying that any clinical protocol that came out took 17 years to actually go and become a standard way of practice. And that have actually been impacting on our ability to actually go and uplift the quality of our patient care. With AI, in fact, if you actually go and take a look at the foundation of machine learning and AI, they are actually very, very similar to how I've actually been doing research and statistical modeling, trying to actually go and sieve out the good ones and understand how we actually go and can congregate to identify the issues. The having an end-to-end view to actually go and ask yourself, how do I actually go on a mission to actually go and bring this to impact on my patient care, have to be one of the first, and if not the very first considerations, because we do want these to actually be the end results of impacting on how we actually go and deliver care better. So that's my first point. The second point, I think, to a certain extent, like I said, we are actually still in the learning phase. In fact, I do anticipate that, and I do hope to see we have a higher failure rate than success rate. That means that we actually, in fact, we should actually be pushing our boundaries and asking ourselves what are the new things we want to try, and we really actually go and try them out, and we, in fact, embrace failure and learn from that. There are actually, in fact, a lot of I wouldn't say failure, but not up to expectations implementation of AI in various industries. So, for example, in IBM, when they actually go and put up Watsons over in MD Anderson's, they try to actually go and deliver a lot of cancer care, but they ended up not having the end-to-end. So I think we shouldn't be afraid to learn from these. And on top of that, we also shouldn't be afraid to actually go and try that on ourselves as well.
And Ben, how do you see it for the cluster and maybe more broadly across the health system?
Okay, so maybe I'll answer a question from the point of what would I like to see AI doing for health, but I'm not sure whether it's achievable in the next 10 years, which is a health avatar for everyone that guides your personalized education, interventions, preventive care. Something that ages digitally or get sick digitally, so you know what to do, what not to do to actually try and preserve it. So a digital twin for everyone.
Thank you, thank you, awesome. And we've come to the end of the panel discussion, and thank you everyone for listening in. We will now can I